Today we are going to give the complete demonstration of this luxury ceiling fan. Okay, this contains a magnetic disc. Here the magnets are placed inside as shown. These are the magnets, and these magnets are placed inside this hole like this. Okay. And all the poles face and have the same polarity. Now here is one of the magnetic discs. You can see all these magnets are inserted this way. Okay. Now here all the magnets are the same polarity. Or either they have all north poles or they have south poles. Okay, this is the magnetic disc. Now we will explain other parts. Here there is a sensor. This sensor will sense this fluorescent paper strip here, which is fixed onto the magnetic disc. So whenever this comes exactly near this, the light will glow here, and the current will pass through the electromagnets through this relay. This is called a solid state relay. Through this solid state relay, the current will be passing through that. Now we will show you. Here is a PC oscilloscope. We will show you how the current is sent in the form of pulses on the screen. And here is a 12 volts battery, and this is the switch. So once I switch on, the power supply will be going to the magnetic disc. And here we have kept, this is blade holder. You can see the holes here. These holes, these two holes together, one blade will be fixed. So there are 12 such blades which we can fix. This is blade holder, and this is only a LED showpiece at the bottom. Okay. So this is the, we can move this sensor left and right through this mechanism, and we can make this fan move clockwise and anti-clockwise also. Right now, because there is no place, we have not fixed the blades, but we will show you the basic motor technology which will run with this 12 volts battery. Here is a multimeter, and you can see the voltage of this multimeter is 12.4 volts. Okay, so now I will start on the switch. There is a small machining problem, and these magnets are weak magnets. That is why it is getting a self start. You can also see. Now see, this is how the fan is rotating. Hi friends, now you can see the fan is rotating. Okay, when the fan is rotating, we will show you on the screen. This is on time and this is off time. That means in this one cycle we are giving only a small pulse of the DC current, and here it is completely off. During this off, there is a voltage developed. The spike what we are seeing here is a voltage developed. Okay. So this is how the efficiency of the fan is increasing. We are not giving continuous current supply. You can see the current supply is only in the form of pulses. Okay. The on time is less off time is more. We can also increase and decrease the off time and on time by changing the width of this strip here. Okay, so here is a sensor. Here is a sensor. The sensor is indicating that it is not taking continuous current, it is taking the form of pulses. Okay, now the most important salient feature of this fan is it is a waterproof fan. You can pour water anywhere while the fan is running. Now see, this is a bottle of water and I am going to pour it on the fan. Okay, while the fan is running. Anywhere. You can pour the water anywhere when the fan is running. That is why this fan has got an international award for the best innovation. Oh, you. So this is how the pulses are. And still there is water droplets here everywhere, and even in these water droplets the fan is still running. That is why we can give a guarantee of 25 years for this fan. One second. So this is a bidirectional feature of this fan. You can keep an IoT kit or else Arduino board kit here. By remote we can move it left and right. We need not change the polarity of the wires. Even while the fan is rotating in the opposite direction, the pulses, we are not altering the direction of the voltage. It is the same thing, and the voltage is, this spike shows the voltage that is developed. You can see the sensor, whenever this light is on, only that point of time the electromagnets get the current supply, and the other time when it is off there is no power supply. That is how the efficiency is increased. There is no laminations in this magnetic disc rotor. The laminations are only very few laminations here in the electromagnets, and the weight of copper is almost 180 grams, which is very less for a 15 kg disc with 12 blades. Now we will make, by moving this sensor, we will try to make it go in the other direction. So this is a motor which can rotate in clockwise and anti-clockwise just by changing this position of the sensor. Now we will try to look at the oscilloscope.